Okay, so after having a look at the classification of polymers, now we are going to see the different methods by which we can prepare polymers. One is the addition method, the other one is condensation method. So in addition method, we can prepare polymers by using polythene, Teflon, polyvinyl chloride, and Orlon. These are the polymers which we can prepare by using addition method. Let's see them one by one. Okay, so polyethene, first of all, we will obviously take ethene molecules. This ethene, n number of ethene molecules will react with each other, undergo polymerization. I'll show you its mechanism also. Polymerization, and they will form ethene molecule getting connected with another ethene molecule. So this is one ethene molecule. We have taken one ethene molecule, we are connecting another ethene over here. Okay, because the double bond has to be broken into a single bond, because we want to attach one more over here, one more over here, one more over here, and we have to attach thousands of ethene like this. So if I go on writing 1,000 times the number of ethene molecules, then it will be very difficult to complete this chapter polymers. शाम तक वही लिखते रहेंगे ethene ethene. तो उससे अच्छा क्या करेंगे कि ऐसा बार बार ethene लिखने से अच्छा what we can do is draw a line, let the line go through the bracket. Okay, it indicates the extension, and write n over here. So this means that this particular is the monomer, and it's going to repeat n number of times to form what? Polythene or polyethene. Okay, so this is very simple. Addition polymers are very simple. Okay, so next, like here we are going to take now polyvinyl chloride. Okay, so this is our vinyl group, and this is our chloro group attached over here, polyvinyl chloride. So polyvinyl chloride, we are again going to take n number of times, and you must have guessed it by now what is going to happen. We're going to let it undergo polymerization. I'll show you its mechanism, both of them. Okay, and then double bond converts into single bond, because we have to attach another group over here, and over here as well. Okay, so because we have to attach n number of groups, we are drawing a square bracket, line will go through it, and we'll write n times, and this becomes polyvinyl chloride. Okay, this becomes what? This is vinyl chloride or chloroethene. Vinyl, we use the word vinyl whenever your functional group is attached to sp2 hybridized carbon. So it is attached to the sp2 hybridized carbon because this carbon is a double bonded carbon. Vinyl chloride will form polyvinyl chloride. Let us see how this exactly happens. So for initiating this reaction, we take something called as benzoyl peroxide. What are we taking? This is your benzoyl, this is your benzoyl. Okay, and now we are writing the peroxide. Okay, benzoyl peroxide. So we take this benzoyl peroxide, and then we'll have to break this into two halves. Like this bond is going to break. We'll break it into two halves, and this is going to form oxygen free radical. That means it's a symmetrical structure, right? Peroxide is always symmetrical. So these are the two structures. Okay, this bond has broken in the center. Like when I say that the bond has broken, it is a homolytic break. One electron was over here, one electron was over here. Bond has broken from the center. So one electron comes on the oxygen. So this is one structure which I have written over here, and this another structure. I'll write it like this. It is written like this. Turn it and write it like this, so that you get two structures of you can say benzoate. Now it's the benzoate structure, but there is no minus charge. It's a free radical. So what is going to happen? This free radical is going to move. Whenever we are showing one electron moving, we show it by a fish hook. When two electrons are moving, we show it by a normal arrow. But when we are showing only movement of one electron, we are showing by a fish hook, that is a single-headed arrow. And this will move over here. These bonds will move over here, and this electron will move over here, and therefore this will form C double bond O. I'm rewriting C double bond O, and that is nothing but CO2 or carbon dioxide. And this phenyl ring will now be with the unpaired electron, and because it is with the unpaired electron, we are calling it as the free radical. Okay, it's also known. This is also called as the free radical mechanism. So this phenyl free radical, we take it in the next step, and we will now introduce the ethene molecule. So ethene molecules, in order to satisfy this carbon, send a pair of electrons over here, and the unpaired electron will automatically come over here on this carbon. Check what happens then when this is donated a pair of electrons. So this carbon will get attached to this. So here we go, we get carbon. Earlier it was free radical, but now it will get attached to CH2. Double bond will convert into single bond, and the unpaired electron has migrated over here, so you get a free radical over here. And because this carbon is not satisfied, another ethene molecule will come and it will get attached in a similar fashion. And this is a never stopping, and free radical will move over here. It is a never ending process. It will just go on and on unless and until you add an impurity like oxygen, or else you stop the supply of ethene. Then only this method, this reaction will stop. Otherwise it will continue to proceed. Okay, it is difficult to control this reaction, and this is what it will form polyethene. This is the mechanism. This entire thing is the mechanism for these two reactions, or for basically for all addition reactions. Okay, these were the reactions and this is the mechanism for it. I'll wait for a second. You can take a screenshot or pause the video and write the entire mechanism and the reactions. Okay, then now after this, you all are writing down, is it? Okay, I'll pause the video. So now we'll continue with the remaining two addition polymers. We have done polyethylene, we have done polyvinyl chloride. Now we have to do Teflon and we have to complete Orlon. Teflon and Orlon are remaining. And also rubbers, they are also kind of addition, but we'll take it in a separate segment altogether. So we are writing now Orlon. Orlon is polyacrylonitrile, also called as PAN. Polyacrylonitrile, also called as artificial wool. सी देखना, इंडिया में ह्यूमंस की पॉपुलेशन ज़्यादा है और शीप की पॉपुलेशन कम है, ठीक है, तो उसकी वजह से हमको आर्टिफिशियल वुल बनाना पड़ता है क्योंकि सबको हम लोग वुल बना के दे नहीं सकते. तो आर्टिफिशियल वुल कैसे बनेगा? बाय दिस प्रोसेस, बाय सिंथेटिक वे, बाय प्रिपेयरिंग इट इन द लैब. इट विल लुक लाइक वुल, बट ये थोड़ा आपने देखा है ना, ब्लैक कलर के ब्लैंकेट्स रहते हैं. ओरिजिनल वुल बहुत ऐसा सॉफ्ट रहता है, बट ये जो ब्लैक कलर के ब्लैंकेट सिंथेटिक वुल से जो बनते हैं ऑर्लॉन से, वो थोड़े से रफ रहते हैं, ठीक है. और नेचुरल वुल में भी एकदम सॉफ्ट वुल चाहिए आपको, तो वो हमारे कश्मीर में एक गोट है जिसका नाम है पश्मीना. वो गोट के लंबे लंबे बाल रहते हैं, ठीक है, तो उसको, उसके बालों से अगर वुल बनाएंगे तो उसको बोलेंगे पश्मीना वुल, विच इज वेरी कॉस्टली. एक एक शॉल लाखों रुपए की भी हो सकती है. उसका स्पेशलिटी ये इतना सॉफ्ट रहता है कि एक आपकी अंगूठी है, राइट, अंगूठी से में से भी वो पूरा शॉल आप पास कर सकते हो. अंगूठी के अंदर से डाल के ऐसा रुमाल के जैसा निकल सकता है, इतना छोटा फोल्ड हो जाता है, पॉकेट में भी रख सकते हो. सो दैट इज द सॉफ्टेस्ट वुल अवेलेबल. Okay, that is pashmina wool. Just for extra information. Now acrylonitrile क्या है? Acrylonitrile CH2 double bond CH single bond CN. ऊपर हम लोग ने जब पॉलीमराइजेशन किया था लास्ट वीडियो में, तो पॉलीमराइजेशन में आपने जो ब्रांच्ड पॉलीमर लिखा है, वो ब्रांच पॉलीमर के एग्जांपल में लिखो ऑर्लॉन. मैंने गलती से पीवीसी लिखवाया था आपको, बट यू राइट ऑर्लॉन ओवर देयर. ओके, तो CH2 डबल बॉन्ड CHCN, दिस इज गोइंग टू फॉर्म अ ब्रांच्ड पॉलीमर. ये है एक्रिलोनाइट्राइल, इसका नाम एन टाइम्स लेने वाले हम लोग उसको, और इसको पहले जैसा पॉलीमराइज करेंगे. कुछ नहीं, एकदम आसान है. एन टाइम्स ले लिया एंड देन CH2 सिंगल बॉन्ड CN n times. So this will become what? Polyacrylonitrile, or which is called as what? Orlon. Okay, so this is the preparation of Orlon. Another one was Teflon. Teflon coating आपने सुना होगा, गाड़ियों पे टेफ्लॉन कोटिंग लगाते थे. आजकल तो PPF वगैरह निकला है, पहले पेंट को माइनर स्क्रैचेस से प्रोटेक्ट करने के लिए टेफ्लॉन कोटिंग लगाते. तो टेफ्लॉन इज व्हाट? बेसिकली इट इज CF2 डबल बॉन्ड CF2, CF2 डबल बॉन्ड CF2. एन टाइम्स ले लो, हमेशा की तरह जो कर रहे हैं हम लोग वही करो. बहुत इजी है ये पॉलीमराइजेशन. एडिशन पॉलीमर्स बहुत इजी है, कंडेंसेशन में आपको थोड़ा लर्न करना पड़ेगा, बट एडिशन इज वेरी इजी. CF2 डबल बॉन्ड का सिंगल हो जाएगा, डबल बॉन्ड का सिंगल बॉन्ड एन टाइम्स. दिस इज नथिंग बट टेफ्लॉन. ओके, एंड दिस वाज टेट्राफ्लोरोईथीन. क्या है ये? टेट्राफ्लोरोईथीन. टेट्राफ्लोरोईथीन पॉलीमराइज करने के बाद में क्या मिला हमको? टेफ्लॉन. So this is the preparation of addition polymers. Rubbers we are taking in our next session.